Hello students, welcome back to physics session. So you can download the Spark Academy app. So you will be having daily live classes, session of clarifications, free material is available, tips and tricks, previous year's questions. So if you are buying any course from the app, you can contact. Admissions are open right now for the short-term crash course and regular. So this is the schedule for the regular YouTube sessions. My session in the week on Tuesday and Friday. So join us for regular updates. So myself Sandhya, today we will be discussing the vectors, all important formulae and previous year's questions. And if you are buying the course from the Spark Academy app, you can use this coupon code. Enter the coupon code SAM10, means you will get the 10% discount, and you will be supporting me with that. So let us discuss the topics. In this session, we are going to discuss basics of vectors. In this, how to represent the vector and how we can find the angle between two vectors, and types of vectors, position vectors, addition of vectors and subtraction of vectors. And we discuss the MCQs about these concepts. And vectors, vector algebra, these rules we can use to solve the questions mainly from the motion in a plane. So weightage of this chapter means weightage of motion in a plane chapter. Relative motion problems, motion in a plane, projectile motion problems can deal by using the vector algebra. So weightage, 2 questions compulsory from the motion in a plane chapter. So let us go through our discussion. Firstly, representation of a vector. In the measurement of physical quantities, the quantities can be divided into 2 types, scalars and vectors. Scalars which have only magnitude, vectors are the physical quantities which have both magnitude and direction. Example, you can give scalar quantities, time, mass, temperature, etc. These quantities can be added, subtracted or multiplied by using normal algebra. But in the measurement of vector quantities like velocity, acceleration, torque, electric field, etc. To measure these quantities, which are vector quantities, we follow the vector algebra. These by using vector algebra, it obeys triangle law of addition. Means we cannot add these quantities simply. Scalar quantities can be added or subtracted using normal algebra, but vectors obeys the triangle law of addition. Or equivalent of parallelogram law of addition. So vector quantities follows in adding, it obeys triangle law of addition or parallelogram law of addition. So here our discussion is how to represent the vector quantity. An arrow over the head of the vector is the representation of a vector. Let A bar is the vector For the representation, we keep the arrow over the head of this vector, and length of the arrow gives magnitude, and head of the arrow gives direction. Length of the arrow gives magnitude and head gives the direction of the vector. Let us say A is equal to, vector A bar is equal to 10 meters due east. Here magnitude is 10 meters and direction is east. So the vector representation is arrow over the head of that vector, or you can represent with the bold letter. That is the representation of a vector. Next, we see how to calculate the angle between the two vectors. Let us take the example. We are given with two vectors A bar, which is making angle 60 degrees with the horizontal, and another vector B bar. So to find the angle between two vectors, we need to connect that vectors tail to tail or head to head. So we have to connect the vectors tail to tail or head to head, and you always keep in mind these points while connecting the vectors. When we shift the vector unchanged, it remains unchanged. Means we are given with the vector in this direction. This vector you can change that place parallelly here or here or here. We can shift that vector from one place to other without changing its direction and length. Then the vector remains unchanged. Now we see how to find the angle between these two vectors. Here vector A bar is making angle 60 with the horizontal and B bar is in this direction. Just we shift this vector, B bar vector, and we connect with the vector A, tail to tail method. So just we are shifting. I did not change the direction of this vector and length. Length and direction is not changed. Now what will be the angle between vectors? Is equal to 60 degrees. And let us see one more example. By connecting head to head, the same vector, just we connect with the vector A bar to the head. So just we are shifting this vector to this place. We are not changing direction. Here angle is 60 degrees. Here these two are vertically opposite, alternate angles. So here also 60 degrees. So we are shifting vector without changing its direction. So the vector remain unchanged. So by connecting tail to tail or head to head, we can find the angle between the two vectors. Let us take one more example. How to find angle between A bar and B bar. And these two are the sides of an equilateral triangle. A bar and B bar and C bar. This is an equilateral triangle. A bar, B bar and C bar are the sides of this equilateral triangle. And from this, we have to find angle between A bar and B bar. So usually you consider here angle that is 60, but it is wrong. It will not be the angle between A bar and B bar. So while finding angle between vectors, we need to connect vectors tail to tail or head to head. So just I am shifting this vector A, then take the angle between tail to tail, and here it is 180 minus 60. So angle between these two vectors A bar and B bar from this equilateral triangle is 120 degrees. Similarly, you can take B and C by shifting this vector. Here angle also same 120 degrees, and here we can take between A and C like 180 minus 60, it will be 120. So to find angle between vectors, we always connect the vectors tail to tail or head to head. So keep in mind, and while shifting the vector parallelly, vector remain unchanged. So you can place that vector at any other point without changing its direction and the magnitude. So this way you can find the angle between two vectors. Next, types of vectors. First type of vector is equal vectors. Equal vectors have the same magnitude and in the same direction. Here, two vectors A bar and B bar, which are moving in the same direction, having the same magnitude. They should have the same magnitude or in the same direction. That type of vectors are called equal vectors. And next, negative vector. We are given with a vector A bar, and negative of this vector is which is in opposite direction with the same magnitude. So let us say B bar. So here magnitude of A is equal to magnitude of B, but A bar is equal to minus B bar. So B bar is the negative vector of A bar. So if any two vectors having equal magnitude but in opposite direction, that vectors are called negative vectors. Let me discuss here. Next type of vectors, coplanar vectors. Vectors which are having the same plane the type of vectors are coplanar vectors. We have three different planes in our coordinate system along x, y, z axis. This is the xy plane and give the directions x, y, z. If vectors lying in this plane, if any two or three vectors lying in this plane, we say they are in the same plane, that vectors are coplanar. Let me give A bar, B bar and C bar, which are in the same plane. That plane is xy plane. And if they are showing in this plane between x and z, that is xz plane. And if you take this plane, this is yz plane. So if any vectors are lying in the same plane, that vectors are called coplanar vectors. And we have one more type of vector, co-initial vectors. Co-initial vectors means all the vectors are started from the same point. So starting point is same. That vectors are called co-initial vectors. And next type of vector is parallel vector. If any two vectors are in the same direction, they are called parallel vectors. Means they can have equal magnitude or different magnitudes, but they must travel in the same direction. That type of vectors are parallel vectors. And we can say the vectors which are in the same direction, They are collinear vectors or parallel vectors also. So vectors which are in the same direction, that type of vectors are called collinear vectors. Parallel vectors need not of same magnitude. If they have same direction, unequal magnitude are also parallel vectors. So these are the main types of vectors: equal, negative, coplanar and co-initial, parallel vector and collinear vectors. Next concept is position vectors. Before this, let me give you idea about unit vector. A unit vector which has magnitude 1, magnitude equal to 1, and it gives only direction of the vector. It gives only direction of the vector. Unit vector can be represented, let us say vector A. Its representation is cap over the head of the vector. So unit vector can be found by taking vector by magnitude of the vector. Let us say A bar is equal to 10 meters east. So we can write vector A bar is 10 meters east by length of the vector, we take it as magnitude. Here length is 10 meters. So magnitude of the vector is 10 meters. It cancels. So unit vector is representing only direction. In this example, it is in east direction. So unit vector is vector by magnitude of the vector. Its magnitude is always equal to 1. Next, let us discuss the position vector. A vector which represents position of a point from the origin. So let us describe the position of a particle in x, y, z coordinate system. X, y, z. And if you write the unit vectors along x, y and z, along x direction unit vector is I cap, along y direction unit vector is j cap, along z direction unit vector is k cap. So it shows the direction I, j, k are the unit vectors along x, y and z. And we are talking about a position vector of a particle. A particle which is at a point P from the origin, which represents the position of a point from the origin. Now, from the origin, the coordinates of that point, x, y, z coordinates at the origin will be 0, 0, 0. And at this point, let us say the coordinates of this particle 4, 3, 5 means these coordinates gives the information about, means 4 units along x direction and 3 units along y direction and 5 units along z direction. So to find the position of this particle from origin having coordinates 4, 3, 5, you need to displace 4 steps along x, 3 steps along y, 5 steps along z direction. So in general, position vector of a particle having coordinates x, y, z, we can represent x into I cap plus y into j cap plus z into k cap. And how to find the magnitude of the position vector is under root of x square plus y square plus z square. Here, for this, about this particle having coordinates 4, 3, 5. Magnitude is nothing but length of this position vector. So we need to take under root. Initial coordinates are x1, y1, z1. Take these are x2, y2, z2. So length of the coordinates means we can take difference in their position 4 minus 0 whole square plus 3 minus 0 whole square plus 5 minus 0 whole square. This gives you magnitude of the position vector which is originating from the origin. And important point about the position vector is change in position vector gives us displacement of the particle. So let me say it is displacement which is equal to change in position. Final position minus initial position gives the displacement of the particle. So we look at this diagram about this particle which is initially having coordinates 4, 3, 5 and it moves to other point Q along x direction. So initially at this point and it moves to point Q. Then position vector, initial position vector, take it as r1 and finally at this point its position vector from the origin is r2 and at this point having the coordinates 5, 2 and 1. So these coordinates are along x, y and z. So if they are asking displacement of that particle by changing its position from P to Q, you need to take it as R2 minus magnitude of R2 minus R1. Means same as like this, under root of 5 minus 4 whole square plus 2 minus 3 whole square plus 1 minus 5 whole square. That gives the displacement of the particle. So this way we can calculate the position vector. So which is giving the position of a point from the origin. Next, addition of vectors. So let us talk about the triangle law of vector addition of two vectors. Here we are given with the magnitudes of OA vector is A and AB vector is B, which are representing the sides of a triangle, and this is the opposite side which gives the addition of these two vectors. So the opposite side of the triangle gives the addition of these two vectors or resultant of the two vectors. We can say it as resultant. So A plus B is equal to C, which is called the resultant of these two vectors. And let us see how to add the vectors with an example. We are given with the two vectors A bar and another vector is in this direction B bar. Now we need to add the vectors. We need to find A bar plus B bar. So we know while connecting the vectors we have to follow tail to tail or head to head method. So to find A bar plus B bar, let us take A bar and connect this vector with the following tail to tail or head to head. So tail of this vector which need to connect with the, let me draw the vector A down. This is vector A. And vector B, initial direction is this way. Now we are just shifting that to this place, and now addition of these two vectors will be resultant of that two vectors C is equal to A plus B. Or if you are adding B bar plus A bar, B bar initial direction is vertically down, and this vector without changing its direction you can connect this way by using tail to tail method. This is B bar and this gives this will be the addition of opposite side of the triangle, give the addition of these two vectors, which is also called as triangle law of vector addition. So here triangle law of vector addition follows the commutative law. A bar plus B bar will be equal to B bar plus A bar. So just we check how to connect the vectors by using the triangle law. So here these two vectors resultant is being the opposite side of the triangle. That way we have connected, and it follows the commutative law, that is A bar plus B bar is equal to B bar plus A bar. Next, subtraction of vectors. So here in this diagram we can observe both vector addition and the vector subtraction. A bar and B bar are magnitudes of OA and AB vectors, are representing the sides of this triangle, and this opposite side of the triangle gives the addition of these two vectors. And if you take the negative of this vector, negative means which is in opposite direction, so negative of that vector gives subtraction of these two vectors. Now B bar is actual direction up, we are taking negative direction opposite to that, and this opposite side of these two will be the resultant of these two vectors, which is subtraction between the vectors. C is equal to A minus B. Next, in the vector addition, next concept is parallelogram law of vectors. The first diagram is showing about the addition of vectors. Here A bar and B bar are representing the sides of parallelogram, and the resultant of these two vectors is being the diagonal of this parallelogram. So C bar is the resultant, which will be equal to A bar plus B bar. In the parallelogram law of vector addition, to find the magnitude of the resultant is A bar plus B bar. To find the magnitude, initially the vectors having angle theta, then the magnitude of the two vectors resultant is under root of A square plus B square plus 2AB cos theta. Here A, B are the magnitudes of vector A bar and magnitude of vector B bar. So under root of A square plus B square plus 2AB cos theta is the magnitude of the resultant, and this resultant vector making angle alpha with the vector A, then the direction of the resultant will be, to find the direction of the resultant, we use the tan component. So tan alpha from this will be equal to B sin theta by A plus B cos theta. You can take the angle with the vector B also. These magnitudes will change. Here we get A sin theta by, if you are taking this angle, let us say beta, then direction of the resultant will be equal to a sin theta by b plus a cos theta. So in the parallelogram law of vector addition, these two results are important. How to calculate the magnitude of resultant and direction of the resultant. Resultant vector is r bar. And let us see here about subtraction of vectors. In the parallelogram law, subtraction of vectors. Here we are taking a bar and b bar representing sides of the parallelogram, and you can see the subdiagram of this. We are taking negative vector of b, which is in opposite direction. Then angle between vector a bar and minus b bar will be 180 minus theta. Then the magnitude of the resultant will be equal to, if a and b are the magnitudes of a bar and b bar, a square plus b square plus 2ab cos 180 minus theta. So it is in the second quadrant. So cos 180 minus theta will be minus cos theta. So resultant of magnitude of the resultant of subtraction of vectors is under root of a square plus b square minus 2ab cos theta. So these are very important results to solve the questions in motion in a plane chapter. Next, see about addition and subtraction of vectors. If the vector is represented along x, y, z axis system, coordinate system, we are given with a bar is equal to ax into I cap plus ay into j cap plus az into k cap. I, j, k are the unit vectors and ax, ay, az are the coordinates along x, y, z axis, or the components of x, y, z. And b bar is bx into I cap plus by into j cap plus bz into k cap. Now adding these two vectors, first let us see addition of these two vectors. The corresponding vectors will be added, means x components, y components, z components will be added in the addition. So we get ax plus bx into I cap plus ay plus by into j cap plus az plus bz into k cap. Similarly, the corresponding components will be subtracted. So a bar minus b bar gives ax minus bx into I cap plus ay minus by into j cap plus az minus bz into k cap. This is vector addition with coordinate system, and it is subtraction with the coordinate system when we are given with the components of x, y, z. And here magnitude of the vector in coordinate system, it is like same position vector under root of x square plus y square plus z square. Here x component is ax, so ax square, y component is ay square, z component is az square. Similarly, magnitude of vector b under root of component of x whole square, component y whole square plus component of z whole square. So this way we can find the magnitude of vectors in the coordinate system and their addition and subtraction. Here you can find magnitude of a plus b also. It will be equal to under root of, now this is the x component, y and z component. It can be written as ax plus bx whole square plus, after adding finding the magnitude of that addition of vectors Az plus Bz whole square. Similarly, for subtraction of vectors, Ax minus Bx whole square plus Ay minus By whole square plus Az minus Bz whole square. It is A minus B. If you are taking B minus A, we need to take Bx minus Ax, By minus Ay, and Bz minus Az. So B minus A is not equal to A minus B. We can write A minus B is equal to magnitude of A minus B is equal to minus of magnitude of B minus. Next, about the vector addition and subtraction. Let us see the important points or short tricks which are helpful to solve the measuring the vector quantities. So we know that resultant magnitude of the resultant of any two vectors is A square plus B square. I am taking here vectors like A square, A and B. So their resultant is A under root of A square plus B square plus 2AB cos theta. So let us see, if angle between the vectors is 0 degrees, means both the vectors are in the same direction, means they are parallel to each other, then the resultant will be equal to, if you put 0 here, it will be A plus B whole square, whereas cos 0 is 1, then the resultant is A plus B, which is the maximum resultant of magnitude of two vectors A and B. And in the second case, if we take angle between the vectors 90 degrees, means they are perpendicular vectors, the two vectors are perpendicular or normal vectors. Normal means being perpendicular to each other. Then the magnitude of the resultant of the two vectors, put cos 90 value here, which is 0. We get under root of A square plus B square. And in the third case, we can take anti-parallel vectors or negative vectors. Theta is equal to 180, means which are in opposite direction, A bar, and now B bar will be negative vector of that A. Then the magnitude of the resultant will be equal to, put theta value 180 here, cos 180 is minus 1. We get A square plus B square minus 2AB. Then A minus B whole square, root cancels, so magnitude is equal to A minus B. It is mod of, you can take highest value minus lowest value. If B is greater, you can consider B minus A. So it also represents high value minus low value. This is the minimum resultant of two vectors. Let us see with the examples of these parallel vectors when theta is 0. There are two force vectors. F is equal to 4 newtons and second force vector is 3 newton. They are in the same direction. Theta is 0. So we can use this result to find the magnitude of these two vectors. Then it will be resultant force of these two vectors will be 4 plus 3, 7. and theta is equal to 90. Here the vectors are being perpendicular to each other, same magnitudes. F2 is 3 newtons, F1 is 4 newtons. Resultant of these two will be between these two vectors. Now this will be the resultant, and can use this result to find the resultant of these two force vectors under root 4 square plus 3 square, which is equal to 16 plus 9, 25. So we are getting resultant force as 5 newtons. And let us check with the anti-parallel vectors or opposite vectors having angle between them is 180. So here these two force vectors are in opposite direction. Can use this result. Then the resultant force is being equal to 4 minus 3, like F1 minus F2, or if it is greater you can take the difference between them, which is equal to 1 Newton. So in vectors, here we are given with two vectors, their resultant is not same in the vector addition every time. It is depending upon the angle. So in vectors, if you take 1 plus 1, it is not always equal to 2. It depends angle between the vectors, like this. So it always depends angle between the vectors. So the resultant of any two vectors lies between, means with this example we can say it lies between 1 to 7. So it can be 2, 3, 4, 5 till 7. It exists between these two values, or it can be 7 and 1, because maximum is 7, minimum is 1 Newton. So resultant of these two vectors less than maximum value and greater than minimum value. This condition we need to keep in mind to solve the magnitude of resultant of any two vectors. So minimum value is less than the resultant of two vectors, magnitude of resultant of two vectors, and that resultant will always less than maximum resultant of the two vectors. Next to see one more case about the parallelogram of vector addition only. If we are given with the equal magnitude of vectors, means magnitude of A, magnitude of B same, let us say that value is F, then the magnitude of the resultant will be under root of F square plus 2F square cos theta. This can be written as 2F square into 1 plus cos theta, and 1 plus cos theta is 2 cos square theta by 2, so which is equal to 4F square cos square theta by 2, its root value is 2F cos theta by 2. So for equal magnitude of vectors, their resultant, we can use this result to find their resultant, 2F cos theta by 2. And let us see about the vector subtraction of equal magnitude. We are given with equal magnitude, means magnitude of A is equal to magnitude of B is equal to, let us take one more vector quantity, that is V. V is the velocity here. Velocity is also a vector quantity. So having equal magnitudes, we are substituting V. Then the resultant will be of these equal magnitudes of vectors v square by following the resultant of vector subtraction. V square plus v square minus 2v square cos theta. So here we can take common 2v square, 1 minus cos theta. It will be 2v square into 2 into sine square theta by 2. 1 minus cos theta can be written as 2 sine square theta by 2. So then the resultant will be 2v sine theta by 2. So equal magnitude of vectors in the subtraction, to find the resultant we can use this result 2v sine theta by 2. In case of addition, for the equal magnitude of vectors, to find the resultant it is being 2f cos theta by 2. You can consider any vector quantity here which have equal magnitude. Here we have taken here force and here velocity. So these are the quite important results to solve the numericals in the motion in a plane chapter. So you download the Spark Academy app to get the great discounts. So in the app there is a free study material, free test will be conducted, and there is a free handwritten notes, previous year's questions and free mock tests will be conducted. So if you are buying the course, you can contact any of these numbers which is displayed. And admissions are open right now. And there is an online coaching available. So don't forget, enter the coupon code SAN10. By using this, you will get the discount. So there are daily on-demand sessions. Yeah, you can go through these all. So our methodology is we start right from the basic concepts, shortcut methods, all model questions, exercise questions, previous year's questions. Chapter-wise tests will be conducted, every weekend test, grand test and test analysis will be given. Yeah, let us see few model questions. These are previous year's questions. So by using that important results, we see how to solve these questions. PYQ means previous year's questions. Here the first question, magnitude of A bar plus B bar is equal to magnitude of A bar, actually it should be magnitude of A bar minus B bar. So let us change the question here. If the magnitude of vector addition is being equal to subtraction of vectors, magnitude of subtraction of vectors, then what is the angle between the A bar and B bar? So you just apply resultant, magnitude of resultant of these two vectors, A square plus B square plus 2AB cos theta is equal to A square plus B square minus 2AB cos theta. You can square on both sides. Root gets cancelled. So then we get A square plus B square, and here the same terms cancel from both sides, and 2AB cos theta is equal to minus 2AB cos theta, which is equal to 4AB cos theta. This gives is equal to 0, then cos theta is equal to 0. So for which angle cos theta 0 means theta is 90 degrees. which is the angle between the A bar and B bar. And the next question, if the sum of the two unit vectors is a unit vector, then the magnitude of their difference is, let us say two vectors A bar and B bar, their sum is equal to resultant, so their magnitudes are equal to 1. Sum of these two are unit vectors and sum of their unit vectors is also a unit vector. So can use the resultant formula whose magnitude is equal to 1. So we substitute their magnitudes 2ab cos theta. So here it is, let us take r square, so it will be 1 square, means here root gets cancelled. Here this side 1 square, because their magnitudes for unit vectors, unit magnitude is 1 plus 2 cos theta. Then we can write 1 is equal to 2 cos theta, and this implies cos theta is equal to 1 by 2. Actually we get here minus 1 because 2 will come this side, 1 minus 2 becomes minus 1. So it is minus 1 by 2. Then theta is equal to 120 degrees. So here just we find the angle between the vectors when their magnitudes equal to 1. But they are asking magnitude of their difference. So now we take magnitude of difference between the vectors, which is subtraction. So here we use the formula a square plus b square minus 2ab cos theta. Here these AB are unit vectors. Again we substitute their magnitudes as 1. So 1 whole square means 1. Again 1 whole square minus 2 into cos theta. Theta value is 120. So we substitute here cos 120 value as minus 1 by 2. So 2 cancel, minus of minus becomes plus. So under root 1 plus 1 plus 1. So difference in their magnitude is root 3 units. When we are given with the two unit vectors, by following vector addition, angle between them is being equal to 120. And for the same unit vectors, the difference is being equal to root 3. Next question. The ratio of maximum and minimum magnitudes of resultant of two vectors A bar and B bar is 3:2. The relation between them is, let us take resultant is maximum with the addition of vectors. So it is given as they are in the ratio, which is the maximum magnitude. They are in the ratio 3:2 is given. So maximum we are taking 2, and the resultant minimum is P minus Q. Its magnitude is 2. If you are taking maximum and minimum ratio, like P plus Q by P minus Q, 3 by 2. Now they are asking what is the relation, they given AB, but I consider vectors like P and Q. No problem. We are taking the same ratio. Here, just a cross multiplication, 2 into P plus Q is equal to 3 into P minus Q. Then we get P 3P minus 2P and minus Q 3 minus 3Q and minus 2q. Take minus 3q value this side, we get 3 minus q is equal to 0. So this simplification gives p is equal to q. Means relation between them is a equal to b, means their magnitudes are equal with this ratio, maximum to minimum. And let us see next question. The resultant of two vectors p bar and q bar is r bar. If the magnitude of q bar is doubled, the new resultant vector becomes perpendicular to the vector p bar. Then what is the magnitude of r? We have to find. So resultant of two vectors p bar plus q bar is equal to r. Then we can take the resultant formula, under root of p square plus q square plus 2pq cos theta. And next they are saying if the magnitude of q is double, so q is equal to 2q. Now we are substituting q is equal to 2q. The new resultant vector is being perpendicular to the p. So here this is p and this is 2q and this is the resultant which is being perpendicular to the vector p bar. So resultant is making 90 degrees with the vector p. So to find the direction of resultant we use tan alpha is equal to q sin theta by p plus q cos theta. So here alpha is 90 degrees. So tan 90 value is infinite is equal to, and here q value is 2q. We need to take when q equal to double the initial value, resultant is perpendicular to initial vector. So we can take 2q sin theta by p plus 2q cos theta. We need to find the magnitude of the resultant. So for that, here p plus 2q cos theta will be equal to 2q sin theta by infinite. So something by infinite value is 0. Then 2q cos theta will be equal to minus p. So when second vector is double the initial value, then 2q cos theta we are taking it as minus p. So substitute this value 2q cos theta value in the resultant of these two vectors. Take it as equation 1 because we need to find the magnitude of r. So r is equal to under root of p square plus q square plus, and it is 2pq cos theta. In the 2q cos theta take it as minus p into yes. So if you simplify this, that is the resultant magnitude of the r value. Here I given few questions. You can solve it and send the answers in chat. Here also you are given with the two questions. I asked the questions about the important results. So one question and there is one more question. So solve and post your answers in comments. So students, this is the required discussion today about the vectors, basics of vectors. Next we have product of vectors and components of vectors. In the next session we continue this. Thank you.